Hey everyone, today we're going to start talking about linear functions um, using graphs to relate two quantities. But linear functions is the big new concept that we're going to be talking about. So using graphs to relate two quantities. So today we're going to be visually representing the relationship between two quantities as they change. So the two quantities are basically the two variables that are either going up or going down, and that's what we're going to be talking about today. So the first example that we have is a balloon as you blow it up. What's happening to the balloon? Well, the balloon is going to either be getting bigger or smaller. That's going to be represented the volume. The volume is how much space is in that balloon. So it's going to start out with not much volume and then get bigger, bigger, bigger until something happens and it goes down. So that's one variable, how big the balloon is going to be. The other variable we're talking about is time. Okay, this could be seconds, this could be minutes. Right now, it's not clear what units I'm talking about, but it's really important when we are looking at these graphs that we're understanding what is being represented on the y-axis, which is volume, how big the balloon is going to be, and on the x-axis, time, how much time is going on. So let's try to break this graph down. As I'm moving along my x-axis, time is going by. So as time goes by, the balloon is getting bigger and bigger, and it's going up the y-axis. So again, we're looking at these two variables as they change and what relationship they have. So from here to here, as time goes on, my balloon's getting bigger. So I can think about that like as I'm blowing into the balloon, it's expanding and the volume is getting bigger. But right here, it flattens out. So it is not gaining any volume. It's staying the same. It's staying the same size, but time is going on. What maybe I could think about is this would be when I am taking a breath and I'm not blowing into the balloon. So right here, I'm blowing up, blowing into the balloon. It's getting bigger, bigger, bigger. Then I stop because I got to take a breath. And during that moment, as time goes on, the balloon is not getting any bigger. Here's where my second breath is going to go in, blowing up the balloon even further. And again, at this point, the volume does not increase because, again, maybe I'm taking my breath, but time is going on. So time continues to go forward, obviously, but my volume of the balloon increases, stays the same, increases, stays the same, increases, and then something happens. It goes all the way down. So I'm following the volume on my y-axis. This could be the moment where the balloon actually pops and all the air is let out, decreasing the volume super rapidly down to zero. Okay, so here's our first example of relating two quantities and seeing how they change and how the relationship that they have with each other. Cool. Yeah, I would get this down and you can mark when it's increasing, when it's constant, when it's increasing, when it's constant, when it's increasing, and then here's where it is decreasing, going down the y-axis. Cool. Feel free to pause this at any time and get this down. For our second example, you do not have to draw all of these graphs. We're going to actually try to tell which is the correct graph based on the data that we have in this table. So the example here is video downloads. On day one, there's a total of 346 downloads. On day two, there's a total of 1,011. Day three, 3,455. And day four, 10,426. What we want to start thinking about is this rate of change that in terms of total downloads, is that constant or not? Is it increasing? Is it decreasing? So if it is increasing or decreasing, is the level that it's increasing constant or not? Well, just roughly looking at these numbers, going from day 1 to day 2, I go from about 300 to about 1,000. So I'm adding 700 new downloads. Okay, let's see if that change is the same. I'm ballparking it here. It's not exactly 700, but we're just getting the general idea. How about going from 1,000 to 3,400? So that's almost 2,500 in terms of the change that's happening. And then lastly, from day 3 to day 4, what's the change there? Well, that's almost 7,000 in terms of the change. Okay, so from this little exercise, we see that my rate of change is not constant. It's certainly increasing day to day, but it's increasing faster and faster and faster with each day. So my problem now is which one of these graphs matches up with this data. Well, I'm looking right here, and I'm seeing that I have a negative slope. And well, before I even look at the slope, I need to look at what the two variables are, what is being compared. Total DL, I stood that for downloads, and here's the day. So day 1, day 2, day 3, day 4. Are my total downloads going down with each day? Is there a decrease in downloads? No, there's not. We talked about it up here. These numbers are going up and up and up. So right off the bat, I can see that that one is not going to match up. How about this one? Still the same variables and on the y-axis and the x-axis. And it looks like it's increasing, which each day there's more and more total downloads. So that kind of matches up with what our data is. But it looks like this slope is a straight line. And that tells me that my rate of change is constant. It's going up by a certain number every single time, a very specific number, that same number every time. But we just established here with the blue ink that that is not the case. It's increasing at a rate that is not constant. So I can tell that this one is not going to work either. How about this one? It's increasing, so that's good. But it looks like it's kind of tapering off, where it was a big increase from day 1 to day 2, and then another increase, but it wasn't as big. And then from 3 to 4, it was an increase, but it got even smaller. That's kind of the opposite of what's happening here, because with each day, I'm getting more and more downloads. I'm increasing even further. I went from 700 to 2,500 to 7,000. So that one's not going to work either. So let's look at this last graph here. It's increasing, which is good, but look at what the slope here. The slope is actually increasing from one day to the other. And that tells me that the change is increasing in terms of the total download. So it's increasing a little bit here. It's increasing a little bit more, and then it really jumps to that last dot there on day 4. And that certainly matches up with what's happening here. We call this exponential growth, is the rate of change is getting steeper and steeper. The slope is getting steeper and steeper. So I know that this graph matches that data that we have in the table there. Cool. Last one. Let's talk about a rocket rises quickly and then slows to a stop as its fuel burns out. It begins to fall quickly until the parachute opens, after which it falls slowly back to Earth. Now, let's represent that with our own graph. You guys are going to be graphing this, just a rough sketch of what's happening here. So before we start graphing this, we need to think about what two variables are being compared here. Well, with a lot of these problems, it's time. Time is going on. And another variable that's being compared is the height of the rocket, right? It's going to go blast off and then going to come back down. So height and time are my two variables. And that's what I'm going to represent here in my graph. Time is almost always on the x-axis, and the height of the rocket kind of makes sense because y is the vertical axis, how high something is representative height there with the y-axis. So let's break down this line and see if it matches up with what we have here. A rocket rises quickly. Here we go, right here. It's being blasted off right here. So this is where it is rising quickly. And then it slows to a stop as its fuel burns out. So here's when it starts to level off. So it's blasting off super quick. At this point, the fuel burns out and it basically comes to a standstill. It doesn't increase in height anymore. It's almost staying at that same height for just a moment right here. So let's represent that. So it stops rising at that point here. What happens next? It begins to fall quickly. Okay, well, here is my decreasing slope, my negative slope, which shows me that it's actually starting to fall back to the earth. We could think that this point right here is Earth, represented as 0, like 0 feet, going up, stopping for a moment. Now it's starting to go back towards the earth, losing elevation, losing its height. So that's why we have a negative slope here. And we're going to say that this falls quickly. But it looks like my slope changes at this point right here. It's still a negative slope, but it's not as steep. So what does that tell me? Well, up here it says it begins to fall quickly until the parachute opens, after which it falls slowly back to Earth. So it's falling quickly here, but slowly here. And we can see that there's a difference in the slope there. Again, they're both negative, but this one's a lot steeper than this. So I know that that point that I just pointed out is where the parachute opens. And after that point, remember we're talking about time here, that's moving across time, is when it slowly falls back to Earth. And that is all I got for you. Feel free to go back and listen to this one more time, take some more notes. But again, we are talking about two quantities. In this case, it was time and height and how they relate to each other. That's what this next section is going to be all about. Thanks for watching.